Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Right now, another installation of the same problem that's sitting on the surface. There is no acceleration up this time, but the force that's trying to push the body is directed under the angle alpha. And alpha is, for example, 30 degrees. So it's kind of pushing the body this way. Alpha is 30 degrees to horizon, but it's also lifting the body. And so it acts in two directions. So they want us to find out what's going on, acceleration, and we by now know that we cannot say up front that it is static or kinetic. We have to check the number. We have to find this critical maximum possible friction of static case. And if this friction satisfies this, so it's less than this maximum, then it's static. But if we find out that our force external pushes more than that, then it's kinetic and then it's moving to the side with acceleration. So as always, I'm never tired of writing second law of motion because it's such a genius law and it's vector, and so I have to put here n vector plus f vector plus mg vector plus f friction vector. And as usual, this is just, I hope you're not watching this as your first problem. I thought you watched previous problems in this playlist. So you know that to determine all the forces you have to draw a picture, and to determine all the forces you have to ask with whom this body is interacting, and it's interacting with Earth, hence gravity is interacting with the surface, hence normal reaction, and because the surface has a friction, it also a friction that's directed this way. And of course it's interacting with external push that pushes is F and the alpha. And so this is vector equation is always x and y, and we can point them anyway, but of course it's only natural to point them this way, because then there would be a lot of things that will disappear. N. No n in this direction. F. All F is exists in this direction. This is F and this is alpha. And I write right away F cosine alpha, because we went through this so many times, and I have a special playlist about how find projections of the vectors. But yes, this is F, this is alpha, and so this is triangle, and this is F cosine alpha, and this is F sine alpha, right? So, but I do it real fast here without too much explanation. mg is vertical, no action on horizontal x, and the friction is this way, so it's minus F friction, and it is ma, and a can be only that way because F pushing that way, so F friction can only compensate and cannot overcome this force that causing this F friction to exist. So this is positive, this is ma, and we have to, if we receive for a negative answer, something is wrong. That's always with friction like this. So n vertically is n, F also is pushing up, and it is F sine alpha, right? Mg, it was 0 here because it was x, but along this axis it's minus mg, right? Friction doesn't exist along this y-axis because it's horizontal, so it's plus 0. And there is no acceleration vertically, so it all becomes like this, right? So we can write the first equation as F cosine alpha plus F friction equal ma. And if a friction is static, acceleration would be 0. But if it's static, a friction cannot exceed this value. So n is actually more important here. I put n here, and I minus f sine, so goes there and plus mg, so n becomes mg minus f sine alpha. And this is the case, but then I have to decide what's going on. Either this is a static case or not. So I can find n, and n would be mg, mass is 1 kilogram, g is 10, 9.8, but I write 10, minus f, and let's put 2 for example. It would be 2, sine 30 degrees is 1/2. If you don't know it, learn it. Go to my playlist, Mathematic Trigonometry and Mathematic Vectors, and you will have 1, 2. And then it would be 9, right? And mu n, the maximum, would be 0.3 multiplied by 9. It would be 2.7. Let's put it here. Let's put it here. And let's figure out who is more, f cosine or this friction maximum, mu n. So we have to compare f cosine, and we have to compare this mu n. Mu n, we know that it is 2.7. And f cosine, f is 2, and cosine of 30 degrees is 1.7 over 2. I just know square root of 3 divided over 2, square root of 3 roughly is 1.7, so it's 0.8, doesn't matter. So this would be on this side, would be, I have no space, so I will write it here. It would be 1.7, and here would be 2.7. So this is bigger, this is bigger, this is bigger. That means that friction, when we apply this force is not enough to move this body. And now let's go to another situation when we have 4 newtons. If we have 4 newtons, then of course n would be 4, and 4 by 2 would be 2, and so it would be 8, right? N would be 8, and mu n would be 0.3 multiplied by 8, it would be 2.4. So this would be 2.4 is the maximum friction that's possible to reach here. And so we're pushing here to the side with f cosine alpha. And we have to compare this with this friction. So f cosine alpha would be the same like before. It would be 4 in this case, multiplied by 0.85. And this mu n would be 2.5 mu n. And this would be 2.5. And 4 multiplied by 0.4, it would be not 1/7 but double. So it would be 3.4. 3.4. This would be the force that pushing it. But the maximum friction in this case is only 2.7. So 3.4 is overcoming, and f cosine is bigger than that. And so if we put a friction just right here, we will receive this equation. So I'm putting this f cosine, and I can put, where is this? F cosine, oh, of course, minus f friction, this is minus, but it affects nothing, it is a typo. So f cosine minus f friction, and the friction I know for a fact that it is mn. And I know that n is this. So I type n mg minus f sine alpha, and this would be ma. And so I know that this is kinetic case, and I can find a from here. I say that it is f cosine minus mu mg minus f sine alpha divided over m. And I will do this math now for you, but before doing this math, what does it mean? It means that f cosine is pushing this way, friction is less, and A should be positive, and friction is less mu by n, but n is also smaller because my force is lifting the body. When I am lifting the body, n becomes smaller because f sine alpha contributes to lifting the body and counteracting mg. So n should counteract less to be balanced in vertical direction. So, and I can put here A, and I repeat, f cosine 60 degrees is 0.85, minus 0.3, mg is 10, f is 4, sine alpha is 1,2, this would be this, and divided over 1. Nobody divides over 1, it's the same. 4 multiplies 0.5, 1.7, 3.4, 3.4, and this is 0.3, 10 minus 2 is 8. Divided over 1, okay, A equal, I will not divide over 1, I will say 3.4 minus 2.4. It would be 1 meter per second squared. And this would be the case in this scenario when I apply force. So, if my force is small enough, then friction, static friction, is enough to compensate for this external force F. But if my force is big enough in this case, then I have the movement. It's exactly like the very first problem that we discussed here. Only in this case what happens, F applied under the angle, so first of all, some portion of F tries to move it and give it acceleration this way, and another portion of F lifts the body up. Lifting the body up means that it presses down less and body reacts less. Body reacts less, critical friction becomes smaller. So, two effects, net effect that I am moving up, moving to the right. And I believe we solved the problem. We see that A is positive, everything is fine, and this is the case, second case of kinetic movement. And I hope those 5 problems were a good introduction to friction, and there would be more on friction naturally, and incline, and tension, and it all would be together, because now you would be proficient with all of this in the same playlist. So don't miss it, subscribe, bell, like, and ask your question and put your comments. Thank you.